This is lesson 6.1, page 356. This is entitled Solving Inequalities Using Addition and Subtraction. On a number line, the graph of an inequality is in one variable is the set of points that represent all solutions of the inequality. Now, as soon as you read the word graph, you might be the way I was at your age, cringing, oh geez, I got to draw these graphs. But it wasn't until I realized that the graphing is actually a shortcut, that's when I started accepting graphing, that hey, the purpose of graphing is to make my work and life easier. When you graph an inequality in one variable, use an open circle for any greater than less than problems, but use a closed circle if it's less than equal or greater than equal. So if you see an equal sign involved, you got to use a closed circle. Now, getting back to what I just said, remember the graphing's actually the shortcut. Imagine if I told you to go home today and I said, I gave you the following directions. I want you to write every single answer to x less than 3 on paper and bring it in tomorrow. Does it make sense that that process would never end? You could write numbers less than 3 forever. That's why you graph it. So what we would do is, you can see here the book puts an open circle at positive 3 and then just draws a line left of it to represent all the answers. That only took me a few seconds, and I'll even provide the number line paper for you. So this should be a quick process. Or look at this. The graph of x greater than equal negative 1. Imagine if I said, go home tonight, and I want you to write down every number out there that is greater than or equal to negative 1, and it would take you forever. Well, on graph paper, we just have to put a closed circle at negative 1 because x does equal negative 1, and then just draw a line to the right, and that represents all the numbers that would be greater than equal negative 1. The graphing's the shortcut. Let's try. Now, they have this problem. They try to give you a real-world example. I have a little issue with it. I'm going to explain why in a minute. The lowest temperature recorded in Antarctica was negative 129 degrees Fahrenheit at the Russian Vostok station in 1983. Use only this fact to write and graph an inequality that describes the temperatures in Antarctica. Well, let's do that. So Antarctica's lowest temperature ever was 129, which would be here. I'm going to close circle it because that temperature did equal negative 129. And it would be any temperatures that were warmer than that. Now this is where I have an issue with the problem in the book. If I just draw an arrow going right forever, that means the Antarctica's temperatures were at lowest negative 129, and they could keep on going up forever, which isn't true. So I don't really like that example. Let's say that Antarctica also had a highest temperature of 40. Well, now if I draw my line going from negative 129 all the way up to 40, now that would be a better example than what the book's using, because the way the book wrote the problem, any temperature greater than negative 129 would be true for Antarctica, and obviously that's not true. I couldn't have had a temperature of like 200. So let's just pretend that the high ever was 40, the low ever was negative 129. That would be a better representation of a sample problem of that in real life. We should also be able to look at a graph and write an inequality. Like if you look at 2, this graph is showing the x values less than 8, so there would be an inequality, x less than 8. Or in this third example, this is showing a picture of inequalities that are equal to negative 2.5. Can you see how it's a closed circle? Or greater. So x is greater than or equal to negative 2.5 would be the correct inequality for that. You learned about equivalent equations in Chapter 3. In Chapter 6, we are going to work with equivalent inequalities. It's the same idea. You use properties of equality to produce equivalent equations. You can use properties of inequality to produce equivalent inequalities. An equivalent inequality are inequalities that have the same solution. So in other words, you're rewriting it, but it's the same thing, or the same solution. We have an addition property of inequality. Adding the same number to each side of an inequality produces an equivalent inequality. Here would be an example of that, a real simple one, like x plus 1 is greater than 2. Well, let me change it to minus 1. There we go. X minus 1 greater than 2. So I can think of onion. I can add 1 to each side. You notice how I'm doing the addition property of inequality. I'm adding 1 to each side. I would get x greater than 3. In other words, I can plug any number greater than 3 to make this true, and it's the same thing up here. If I plug in any number greater than 3, this will be a true statement. Like, let's plug in 3.1. 3.1 minus 1 is 2.1, and 2.1 is greater than 2. So do you notice how we've done that already this year? We just did it with equations. Now we're doing it with inequalities. Let's try a couple. Solve the inequality, graph your solution. So for this example number 4, I have to get rid of minus 9 from x. So I'm going to add 9 to each side, which gives me x less than equal 12. And then I want to graph this. So you can see I just extended my number line to fit 12 on there. So I will put a closed circle at 12, and then you can see that I drew a line left of 12 because, again, I want to show the values for x that are less than or equal to 12. So all these values, and arrow left, anything this way would be less than or equal to 12. And here's one more sample, p minus 9.2 less than equal negative 5. I can add 9.2 to each side. These cancel. P would be less than, if I'm doing my mental math right, that would be 4.2. So now I can graph this. So I'm going to put an open circle this time at around 4.2 because, do you notice? It did not say equal, wrong page. It didn't say equal, it just said less than. And I will draw left of that. Anything left of 4.2 would be a correct response to this. There is also a subtraction property of inequality. If you subtract the same number from each side of an inequality, you will always produce an equivalent inequality. Here would be a sample of that. Solve y plus 5.5 is greater than 6. Graph your solution. Well, to get y by itself, I have to take away 5.5 from each side, which will cancel these out. And I'm going to find out that y is greater than 0.5. Now remember, there's a whole bunch of correct answers to that. I can't write them all out. That's why they're telling me to graph my answer. Okay, so if I go to graph it, 0.5 is about here, and I want the values greater than that, which is why I'm drawing my arrow. I'm going right of that. There's the values greater than 0.5. Real-world problems can be set up with inequalities, like this one, luggage weights. You are checking a bag at the airport. Bags can weigh no more than 50 pounds. So no more means, let's think about that, no more means it's got to weigh less than or equal 50 pounds. Your bag weighs 16.8 pounds. Find the possible weights that you can add to your bag. So if you take the current weight of your bag and you add more weight, it can't be more than 50 pounds. So you can see they wrote an equation here. They wrote 16.8 plus W is less than equal 50. I shouldn't have called that an equation. It's an inequality, but there's an equal in it, so I just wasn't thinking. It's an inequality. Now, I want to solve the inequality. So, I can take 16.8 plus W is less than equal 50. I can get W by itself by taking away 16.8. And I'm finding out that W is less than or equal to 33.2. So I could add up to 33.2 pounds. So if I go to graph this, got to be a little careful here. If I go to graph it, let's do that. We should think a little bit. Now 33.2 would be about here. I'm coloring in my circle now. I don't want to just aimlessly draw a line left, because that would mean I could add negative 70 pounds, for example, of weight, which doesn't make any sense. The least I could add is 0, so we probably ought to just draw this from 33.2 down to 0, and that any weights in this range would give us an amount that we could add to our luggage. So I'm going to pause the video here. If you have questions, make sure you ask during class.